built a cannon so massive it needed its own railway system and took 500 men just to operate. But here's what nobody tells you about the biggest guns ever created. They were basically useless.
Between 1914 and 1945, military engineers across the globe lost their minds. I'm talking about weapons so ridiculously oversized, so impractically huge, that looking back, you have to wonder what they were thinking. Today, we're diving deep into three of the most absurd war machines ever constructed. We're talking about guns the size of buildings, tanks that look like Ferris wheels, and armored beasts so heavy they couldn't even cross a bridge. By the end of this, you'll understand why bigger isn't always better and why these metal monsters were destined to fail before they even fired their first shot.
Let's set the stage here. When you're in the middle of a massive war, desperation kicks in. Engineers and military leaders start thinking that maybe, just maybe, if they build something big enough, powerful enough, and intimidating enough, they can end the war in one decisive blow. It's the ultimate power fantasy turned into steel and explosives. But here's the issue. These weren't just big machines. They were so massive that they created problems nobody had even thought about. How do you move a weapon that weighs more than 1,000 cars? How do you hide something that can be seen from miles away? How do you feed it ammunition when each shell weighs as much as a small car? And most importantly, how do you justify spending millions of dollars and thousands of man-hours on something that might fire a handful of shots before becoming completely obsolete? The three machines we're about to discuss represent the peak of this kind of thinking. They're masterpieces of engineering and monuments to human ambition. They're also some of the biggest military failures in history. And the craziest part? Two of them actually saw combat. One of them even worked. Sort of.
Let's start with the absolute king of oversized artillery, the Schwerer Gustav. This thing wasn't just a big gun. It was a statement. It was Germany saying to the world, look what we can build. Picture this. It's 1942. Adolf Hitler has been obsessed with breaking through the Maginot Line, this massive system of French fortifications that were supposed to be unbreakable. Standard artillery wasn't going to cut it. Tank shells bounced off. Bombers couldn't penetrate deep enough. So Hitler went to Gustav Krupp, head of the famous Krupp Armaments Company, and basically said, build me something that can destroy anything. And Krupp delivered. Oh boy, did he deliver. The Schwerer Gustav was completed in 1941, and when I tell you this thing was massive, I need you to really understand what that means. This gun was 155 feet long. That's about half the length of a football field. It weighed 1,350 tons. That's 2.7 million pounds. To put that in perspective, that's heavier than 600 cars combined. The barrel alone was 98 feet long and weighed 400 tons. But the size was just the beginning. This monster required 250 men just to assemble it. Once assembled, it needed a crew of 500 soldiers to operate. Not 50, not 150, 500 people, just to fire one gun. It required 2 parallel railway tracks because it was too heavy for a single track. Engineers had to lay down special reinforced rails wherever it went. And get this, it took 3 weeks to set up. 3 entire weeks just to get it ready to fire. The ammunition was equally insane. The Gustav fired 2 types of shells. The high explosive shell weighed 10,584 pounds. That's over 5 tons. The armor-piercing shell was even heavier, at 15,653 pounds. That's almost 8 tons of steel and explosive being launched through the air. Each shell was so big that it had to be loaded using a specially designed crane system. You couldn't just have a couple of soldiers shoving shells into the breach. This required machinery, coordination, and perfect timing.
When the Gustav fired, it was an event. The explosion was so powerful that anyone standing nearby without ear protection would suffer permanent hearing damage. The gun would recoil with such force that the entire assembly would shift backward on its rails. The shell would arc through the sky at speeds over 2,000 miles per hour and could hit targets up to 29 miles away. When it landed, the high explosive shell could create a crater 30 feet wide and 30 feet deep. The armor-piercing shell could punch through 23 feet of reinforced concrete or 7 feet of steel armor. Now here's where it gets interesting. The Gustav had a sister gun called Dora, basically identical in every way. Same size, same weight, same absurd requirements. Germany built two of these things. Why? Because apparently one wasn't enough of a logistical nightmare. Dora was deployed first, sent to the siege of Sevastopol in 1942 on the Eastern Front. This was a major Soviet naval fortress in Crimea, and it was heavily fortified. The Soviets had underground ammunition depots, concrete bunkers, and artillery positions that had resisted German attacks for months. The Germans brought in Dora, thinking it would be the solution to all their problems. And you know what? It actually worked. Kind of. Dora fired around 48 rounds during the siege. It destroyed an ammunition depot that was buried 100 feet underground beneath the bay. It demolished fortified positions. It created massive psychological impact on the Soviet defenders who had never seen anything like it. The siege eventually fell, and Dora could claim at least some credit. But here's the reality check. Those 48 shots took enormous resources. Each shell cost about as much as a small house. The 500-man crew had to be fed, housed, and protected. The gun itself was a massive target. If Soviet aircraft had located it, bombers could have destroyed it while it sat there helpless on its rails. Moving it was a multi-day operation that required dedicated trains and engineering teams. And at the end of the day, conventional artillery and aircraft probably could have accomplished the same thing with a fraction of the cost and effort. Gustav, the original gun, saw even less action. It was deployed to Leningrad, but never fired a shot in combat there. It was moved around a bit, fired some test shots, and basically spent most of the war sitting around being a very expensive piece of metal. By 1945, with the Soviets closing in, the Germans destroyed both guns to prevent their capture. They blew them up and scattered the pieces. So what's the lesson here? The Schwerer Gustav and Dora represent the ultimate expression of bigger is better mentality. They were engineering triumphs. The fact that humans in the 1940s could design and build something that massive and that powerful is genuinely impressive. But they were also tactical failures. They were too big, too slow, too expensive, and too vulnerable. They represented thousands of man-hours and millions of dollars that could have been spent on tanks, aircraft, or literally anything more practical. And yet, there's something almost beautiful about their absurdity. These guns existed at the absolute limit of what was physically possible. They pushed engineering to its breaking point. They were built because someone asked, "Can we do this?" and refused to accept no as an answer. They're monuments to human ambition and human foolishness in equal measure. But as crazy as the Gustav and Dora were, they at least made some kind of sense. They were big guns designed to destroy big fortifications. Our next machine doesn't even have that excuse.
Let's rewind back to 1914. World War I has just started. Trench warfare is beginning to solidify across the Western Front. Armies are realizing that traditional cavalry charges and infantry assaults are getting absolutely shredded by machine guns and artillery. Everyone's looking for a solution, some kind of armored vehicle that can cross trenches, break through barbed wire, and lead infantry into enemy positions. In Russia, engineer Nikolai Lebedenko had an idea, and it was one of the strangest ideas in military history. Most people, when they think about crossing a trench,
Imagine something with tracks or wheels that can simply roll over obstacles. Lebedenko thought different. He looked at a child's tricycle and thought, what if we made that, but absolutely enormous? I'm not making this up. The design was reportedly inspired by watching a child play with a toy tricycle. Lebedenko noticed how large front wheels could roll over small obstacles easily. So he scaled that concept up to something that could crush barbed wire, cross trenches, and carry heavy weapons. The result was the Tsar Tank, also called the Lebedenko tank, or simply the Netopir, which means bat in Russian. This machine looked like something out of a fever dream. Imagine two absolutely massive spoked wheels at the front, each one 27 feet in diameter. That's about as tall as a three-story building. These wheels were connected by an axle that held a large turret in the center. Then at the back, there was a smaller trailing wheel about 5 feet in diameter that was supposed to steer the whole contraption. The entire vehicle was over 60 feet wide and weighed around 60 tons when fully loaded. It could theoretically carry a crew of 10 men, plus multiple machine guns and possibly light artillery. The logic was simple. Those giant front wheels would roll over trenches and obstacles like they weren't even there. The height would give the guns a commanding view of the battlefield. The sheer size would intimidate enemy soldiers. And the spoke design would make it lighter than a solid wheel of the same size. On paper, it almost made sense. Almost.
Lebedenko was passionate about his design. He managed to get an audience with Tsar Nicholas II himself in 1915. He brought a small working model to demonstrate the concept. The Tsar was apparently intrigued. Remember, this was a time when tanks were still a new concept. The British hadn't even deployed their first tanks yet. Nobody really knew what would work and what wouldn't. So the Tsar approved funding for a full-size prototype. Construction began in 1915 near Moscow, in a heavily wooded area to keep the project secret. It took months to build. Workers had to construct the massive wheels, the frame, the turret, everything from scratch. Two 240-horsepower engines were installed, one for each front wheel. The engines came from a German airship that had been shot down over Russia. This was cutting-edge power for the time. By August 15th, the prototype was ready for testing. Engineers, military officers, and workers gathered to watch this massive machine take its first steps. The engines roared to life, the giant wheels began to turn, and for a brief moment, it actually worked. The Tsar Tank rolled forward, crushing small trees and brush beneath its enormous wheels. The front wheels climbed over logs and obstacles. It looked like Lebedenko's crazy vision might actually succeed. Then it hit soft ground. See, here's the problem nobody had fully considered. Those massive front wheels distributed weight over a large area, which was good. But that tiny rear wheel? All the weight of the back of the vehicle was concentrated on that one small point. And when that wheel hit soft soil, it immediately sank. Not just a little bit. It sank deep into the mud and completely lodged itself. The engine strained, the front wheel spun, the crew tried everything. But the Tsar Tank was stuck. And I mean really stuck. It wasn't going anywhere without serious help. Engineers tried to solve the problem. They experimented with different approaches. They tried pulling it out with cables. They tried digging out the rear wheel. Nothing worked. The fundamental design was flawed. That rear wheel was always going to be a weak point. Any soft ground, any mud, any loose soil, and the whole vehicle would become immobilized. But it got worse. Even when they did manage to get it moving on hard ground, other problems emerged. The vehicle was incredibly slow, barely managing 3 miles per hour at best. It was impossibly loud. The engines were underpowered for the weight they had to move. The steering was terrible because it relied entirely on that small rear wheel. And the whole structure was incredibly unstable. It swayed and wobbled as it moved. Firing guns from the turret while moving would have been nearly impossible.
And then there was the most obvious problem. This thing was enormous. You could see it coming from miles away. There was no element of surprise. No camouflage would hide a vehicle with 27-foot-tall wheels. Enemy artillery would have a field day. They wouldn't even need to aim carefully. Just point in the general direction of the giant tricycle tank and fire. The Tsar Tank sat in those woods for years. Nobody knew what to do with it. The project was quietly abandoned. By 1917, Russia was in the middle of a revolution. The Tsar was overthrown. The country descended into civil war. Nobody cared about the giant experimental tank sitting in the forest. Eventually, it was scrapped for metal. The engines were removed and used elsewhere. The wheels were cut apart. Within a few years, nothing remained except some photographs and documents. The Tsar Tank became a footnote in history, a bizarre experiment that proved bigger isn't always better. But here's what makes the Tsar Tank fascinating. It represents a moment in time when everything was on the table, when engineers were willing to try anything, no matter how strange, because they genuinely didn't know what would work. The British were developing rhomboid-shaped tanks. The French were building massive steel boxes on tracks. The Germans were experimenting with giant armored cars. Everyone was throwing ideas at the wall to see what stuck. The Tsar Tank didn't stick, but it tried. And there's something admirable about that, even if the result was a 60-ton tricycle that couldn't get out of its own way. At least the Tsar Tank was built during a time of experimentation. Our final machine has no such excuse.
By 1942, Germany should have learned its lesson about oversized war machines. But instead, they doubled down. They looked at the concept of a heavy tank and asked, what if we made it so heavy that it literally couldn't cross most bridges? Enter the Panzer VIII Maus, the heaviest, fully enclosed armored fighting vehicle ever built. And let me be clear right from the start, this thing was absolutely ridiculous. The story begins with Ferdinand Porsche. Yes, that Porsche, the same guy who would later create the sports car company. During World War II, Porsche was one of Germany's top tank designers. He had a history of creating unusual designs. Some worked, many didn't, but he always thought big. In 1942, Hitler was becoming increasingly obsessed with heavy armor. The German army was facing new Soviet tanks like the T-34 and KV-1 that were proving difficult to destroy. Hitler wanted something invincible, something that could dominate any battlefield, something that no enemy weapon could penetrate. Porsche took that directive and ran with it. He proposed a tank that would weigh 188 tons. That's 376,000 pounds. To put that in perspective, a modern M1 Abrams tank weighs about 60 tons. The Maus was 3 times heavier than one of the heaviest tanks in service today. The name Maus means mouse in German. It was supposed to be ironic, like calling a huge guy tiny. But the code name actually became official, and now we're stuck with the image of a 188-ton Maus. The armor on the Maus was insane. The front hull was 7.9 inches thick. The turret front was 9.4 inches thick. The sides were over 7 inches. The rear was 6.3 inches. Even the roof had 7.6 inches of armor. This was more armor than some bank vaults. It was designed to be effectively immune to any anti-tank weapon in existence at the time. For weapons, the Maus carried a 128mm main gun and a coaxial 75mm gun. The 128mm was one of the most powerful tank guns of the entire war. It could destroy any Allied tank from well beyond their effective range. The 75mm was there for lighter targets and infantry support. The tank also had a machine gun for close defense. On paper, this sounds amazing. a slow-moving fortress that nothing could stop. But reality is never that simple. First problem: weight. At 188 tons, the Maus was too heavy for basically every bridge in Europe. Standard bridges were rated for 30 to 40 tons maximum. Even reinforced military bridges couldn't handle the Maus. So Porsche's solution was to make the tank submersible. The idea was that it would cross rivers by driving along the bottom. A second Maus on the shore would provide electrical power through a cable, since the engine couldn't run underwater. Let me repeat that. The solution to the tank being too heavy for bridges was to make it drive underwater. This is the kind of logic we're dealing with. Second problem: speed. The Maus could theoretically reach 8 miles per hour on roads. In practice, it was closer to 5 or 6 miles per hour. Cross-country, it would be even slower. This thing moved like a 188-ton tank. Any enemy that saw it coming would have plenty of time to retreat, reposition, or call in air support. Third problem: the engine. The Maus was powered by a Daimler-Benz MB509 engine originally designed for aircraft. It produced about 1,200 horsepower. That sounds like a lot until you remember it has to move 188 tons. The power-to-weight ratio was terrible. The engine constantly overheated. It guzzled fuel at an alarming rate. The Maus got about 1 mile per 4 gallons of fuel. That's 0.25 miles per gallon. To put that in perspective, driving 60 miles would require 240 gallons of fuel. Fourth problem: maintenance. Everything about the Maus was custom built. The suspension, the tracks, the transmission, all of it was unique to this one vehicle. If anything broke, you couldn't just grab spare parts from another tank. You'd need specially manufactured components. In the middle of a war, when German industry was being bombed daily, this was a logistical nightmare. Fifth problem: production. Each Maus took enormous resources to build. Thousands of man-hours, rare materials, specialized facilities. Germany was already struggling to produce enough normal tanks. Diverting resources to build super-heavy tanks that might not even be useful was questionable at best.
But despite all these obvious problems, Hitler loved the idea. He pushed for the Maus to be developed and tested. Porsche received approval to build prototypes. By 1944, 2 prototypes were completed. The first was called V1, the second, V2. V1 had a functional chassis but no turret. V2 had a turret but engine problems. Neither one was fully operational in the way a combat vehicle should be. Testing began at Kummersdorf, a German military testing ground, and immediately problems showed up. The tank was so heavy it tore up roads. The ground pressure was enormous despite the wide tracks. In soft soil, it would sink. The engine overheated constantly. The transmission failed repeatedly. The fuel consumption made long-distance travel impossible. But the biggest problem was timing. By 1944, Germany was losing the war. The Soviets were pushing from the east. The Allies had landed in France and were pushing from the west. German cities were being bombed around the clock. The last thing Germany needed was experimental super-heavy tanks that barely worked. Production plans were quietly canceled. The 2 prototypes were left at the testing grounds. In early 1945, as Soviet forces approached, German engineers were ordered to destroy the prototypes to prevent capture. They used explosives to blow them up. But here's where it gets interesting. The Soviets captured the remains anyway. They found parts of both prototypes in the ruins of the testing ground. Soviet engineers examined the wreckage with great interest. They took detailed notes. They photographed everything. They wanted to understand what the Germans had been thinking. Eventually, the Soviets decided to do something clever. They combined the surviving parts of V1 and V2 to create one complete Maus. The hull from V1 and the turret from V2 were merged together. This Frankenstein Maus was shipped back to the Soviet Union for further study. Today, that tank is on display at the Kubinka Tank Museum outside of Moscow. It's the only surviving Maus in the world. It sits there as a testament to engineering ambition and military impracticality. You can visit it, walk around it, and see just how absurdly massive this thing really is. So what went wrong? Everything, really. The Maus was a solution in search of a problem. Germany didn't need invincible super-heavy tanks. They needed reliable medium tanks they could produce in large numbers. They needed better logistics, better fuel supplies, better strategic planning. The Maus represented a fundamental misunderstanding of what modern warfare required. But there's a deeper issue here. The Maus was a product of desperation and ego. Hitler wanted wonder weapons. He wanted machines that would turn the tide of the war through sheer impressiveness. He wanted tanks that couldn't be killed, guns that couldn't miss, rockets that couldn't be stopped. The Maus was part of that fantasy. And it's not like German engineers didn't know better. Many of them raised concerns. They pointed out the obvious problems. But when your boss is a dictator who doesn't like hearing no, you either build the tank or risk serious consequences. So, they built it. The Maus represents the absolute peak of heavy tank design. Nothing heavier has ever been built and fully assembled. There have been proposals for larger tanks, but none were constructed. The Maus stands alone. And it stands as a warning about what happens when you prioritize size and power over practicality and efficiency.
So here we are. 3 machines, 3 different wars, 3 different countries, and 3 spectacular failures. But what connects them? What's the deeper lesson here? It's about human nature, about our tendency to believe that bigger is always better, about our fascination with size and power, about the seductive appeal of wonder weapons and game changers. The Schwerer Gustav and Dora were built because Hitler wanted to break the Maginot Line. They succeeded in destroying fortifications at Sevastopol, but at what cost? Millions of marks, thousands of man-hours, and resources that could have been used for more practical weapons. They were engineering masterpieces that proved engineering isn't everything. The Tsar Tank was built because Lebedenko genuinely believed his tricycle design could work. He wasn't trying to build something impractical. He thought he'd solve the problem of trench warfare. But good intentions don't overcome bad physics. The Tsar Tank failed because the fundamental design was flawed from the beginning. No amount of tinkering could fix the fact that a small rear wheel would always sink in soft ground. The Maus was built because Hitler wanted invincible tanks, and Porsche wanted to build them. It was ego and desperation wrapped in 188 tons of steel. It represented everything wrong with late-war German military planning. Instead of focusing on what they needed, they built what they wanted. But here's the thing. We can laugh at these failures now. We can shake our heads at the absurdity. But at the time, these were serious projects undertaken by smart people who genuinely thought they would work. Engineers, designers, military leaders. They all believed these machines would make a difference. And in a way, they did. Just not the difference they intended. These machines taught future generations valuable lessons. They showed that mobility matters more than armor, that logistics matters more than firepower, that practical beats impressive every single time. Modern military doctrine is built on these lessons. Tanks today are designed to be fast, reliable, and maintainable. Artillery is designed to be mobile and flexible. Nobody is building 1,350-ton railway guns anymore because we learned that lesson.
There's also something deeply human about these machines. They represent our desire to overcome obstacles through sheer force and size. When faced with an enemy fortification, we want to build a bigger gun. When faced with a trench, we want to build a bigger vehicle. When faced with enemy tanks, we want to build a bigger tank. It's intuitive. It makes emotional sense even when it doesn't make logical sense. That's why these stories matter. Not because these machines succeeded, but because they failed. They failed in spectacular, expensive, and educational ways. They failed so that future generations wouldn't make the same mistakes. Think about the resources that went into these projects. The Schwerer Gustav and Dora required years of design work, specialized manufacturing facilities, rare materials, and hundreds of workers. The Tsar Tank required imperial approval, funding, and months of construction. The Maus required some of Germany's best engineers, precious resources, and time they didn't have. Now imagine if those resources had been used differently. What if instead of building 2 giant railway guns, Germany had built 100 normal artillery pieces? What if instead of the Tsar Tank, Russia had developed more reliable armored cars? What if instead of the Maus, Germany had built 200 more Panther tanks? The answer is that the wars might have gone differently. Maybe not. Maybe these projects were drops in the bucket compared to the larger strategic failures. But at the minimum, those resources wouldn't have been completely wasted on machines that barely worked. Yet we can't ignore the wonder these machines inspire. Even today, people are fascinated by the Schwerer Gustav. Photos of the Maus draw crowds at museums. The story of the Tsar Tank gets retold because it's just so bizarre. These machines capture our imagination in a way that normal, practical weapons don't. There's a reason the largest gun ever built is more interesting than the 10,000th normal artillery piece. There's a reason the heaviest tank ever made draws more attention than reliable medium tanks. There is a reason a giant tricycle tank is more memorable than conventional armored cars. Size and ambition create stories, and stories last longer than statistics.
So maybe these machines weren't complete failures. They failed at their intended purpose, yes. They failed to change the course of wars. They failed to justify their enormous costs. But they succeeded in capturing human imagination. They succeeded in teaching us lessons. They succeeded in becoming legends. And legends, unlike the machines themselves, never die. The Schwerer Gustav was destroyed in 1945, but we're still talking about it 80 years later. The Tsar Tank was scrapped, but its story lives on. The Maus was blown up, but the one surviving example is one of the most photographed tanks in the world. These machines represent humanity at our most ambitious and most foolish. They represent the gap between what we want to build and what we should build. They represent the moment when engineering capability runs headfirst into practical reality. And they represent a kind of innocence, a belief that any problem can be solved by building something big enough. We don't build machines like this anymore. Modern military design is focused on efficiency, cost-effectiveness, and practicality. We use drones instead of giant guns. We use networks instead of massive armor. We learned that intelligence matters more than size, that speed matters more than power, and that flexibility matters more than strength. But sometimes, late at night, when military engineers are dreaming, I bet they still imagine what it would be like to build something truly massive. Something that would make people stop and stare. Something that would be remembered for generations. Something like a 1,350-ton railway gun, or a tank with 27-foot wheels, or a 188-ton armored fortress.
They probably wake up and remember all the reasons why that's a terrible idea. But for just a moment, they let themselves dream about building monsters.
These three machines, the Schwerer Gustav and Dora, the Tsar Tank, and the Maus, they're more than just military hardware. They're monuments to a specific kind of thinking. The kind that says, if it's worth doing, it's worth overdoing. The kind that says, don't just solve the problem, overwhelm it. The kind that says, let's build something nobody will ever forget. And you know what? It worked. We haven't forgotten. 80 years later, we're still talking about them. We're still fascinated by them. We're still trying to understand what possessed people to build them. The Schwerer Gustav fired a few dozen shots in anger and then was destroyed to prevent capture. The Tsar Tank got stuck in the mud during its first real test and was abandoned. The Maus never saw combat at all, destroyed before it could be used. By any practical measure, these were wastes of time, money, and effort. But they're also incredible pieces of history. They're physical proof that humans will always push boundaries, always test limits, always ask, what if? They prove that engineering isn't just about what works, it's about what's possible. They prove that sometimes the most interesting projects are the ones that fail. If you ever get the chance to see the surviving Maus at Kubinka, take it. Stand next to those massive tracks. Look up at that enormous turret. Try to imagine what it would be like to see that thing rolling toward you. Then remember that it was too heavy to cross bridges, too slow to be useful, and too expensive to produce. Remember that it represents everything wrong with late-war German planning, and yet it's still incredible. The same goes for the stories of the Gustav and the Tsar Tank. Read about them. Look at the photos. Try to imagine what it must have been like to watch a 27-foot-tall tricycle tank attempt to drive through a forest, or to see a gun so large it needed its own railway system. These are stories worth knowing, not because they're stories of success, but because they're stories of ambition.
In the end, these machines teach us something important. They teach us that failure is often more interesting than success, that the craziest ideas sometimes get built, that size isn't everything, that logistics matters, that practical beats impressive, and that sometimes the best thing you can do is learn from someone else's mistakes. The age of giant war machines is over. We're never going to see another Schwerer Gustav, another Tsar Tank, or another Maus. Modern warfare has moved in completely different directions. But the spirit that created these machines, that drive to build something bigger and more powerful than anyone thought possible, that's still with us. It just expresses itself in different ways now. So the next time someone proposes building something ridiculously oversized, something that seems impressive but impractical, remember these three machines. Remember that bigger isn't always better. Remember that what looks good on paper might sink in the mud. Remember that sometimes the most expensive solution is also the worst solution. But also remember that these machines existed, that people built them, that for a brief moment these metal monsters walked the earth, and that even though they failed, we're still talking about them generations later.